Hello and welcome. Today we are going to understand regular expressions in greater detail. So before we begin, let us understand that a regular expression is nothing but a string. Okay? But what it is it actually describes a pattern that your input string should conform to. Okay? So let us see how we can write this pattern. Let us say that we have a very simple pattern as A, B, C, D, E. So what does that mean? This means that whatever your input string is, it should be an A followed by a B followed by a C followed by a D followed by a E to return a true value from this matches method. That is what it means. And we all know that this matches method actually compares the whole of the input string with the whole of the regex. That is, your input string should be exactly A, B, C, D, E, nothing more or nothing less. Alright? So let us see if this is the case. And yes, that is the case and it's true. So let's just check if we give something else, what the output is. Yeah, so it is false. So this was a very simple regular expression, but it does show us how regular expressions work in general. Okay? Now let us say that you had a name and your name was Messi. Okay? And you wanted to see whether or not the input string is the same as your name. So you could make use of regular expressions to achieve this in this following way. So set the regular expression as the pattern that you want your input string to follow, and that is in small m followed by a small e, s, and I. So now you can check whether or not the input string corresponds to this pattern. So Java C test. Yes, so the input string does not is not your name basically. But yeah, if the input string was this, then this would be identified as true. This is the simplest example of a regular expression. But notice that this has a few limitations. That is because we have not really discussed regular expressions and their full powers in detail. Okay, so say suppose you entered this, a capital M, followed by a small e, small s, and I. So this is going to be identified as false by this matches method, because the regular expression expects you to have a small m followed by small characters all the way. But then here you have a capital letter. So let us see if that is the case. And yes, you will see that it is a false value that is being returned. So how to correct this? So you need some mechanism to specify that this first letter can be either a capital M or a small m. How do you do that? Well, in order to do that, regular expressions make use of square brackets. Now you can give any letter inside of these square brackets, okay, as many as you want. And all that this would mean is that this position, okay, this position can be occupied by any one of the letters present here. Now you can see that there are many repetitions here. I did not mean to do that, but yeah. So this position can be either occupied by an F, a D, S, N, I, O, okay, all the way. Get it? So in our case, what did we need? Either a capital M or a small m. So here we go. Now we are done with it. So if we compile this time we get a true value, because this was a capital M, and we had stated that this first position can be occupied by either a capital M or a small m. So yes, this does confirm to this. So let us see if the original name works as well. It should, and it does. So it's a true value that is being returned. That is exactly what we wanted. Okay, so that was good. But suppose you wanted a string such that, or suppose you wanted to create a regular expression that just matches one English small character. One small character from the English alphabet. Just one. It could be anything. So how do we do it? Okay. So I had just told you about the square brackets, and anything that is present within the square brackets basically represents some kind of an option. That is, if you have A, B, C, this position can be occupied by either an A or a B or a C all of these are going to match the regular expression. So our original question that we are trying to answer in this is what to do if we want to match one small English character, lowercase character. So logic would say that we are going to do E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So now I think we can say that we can match any small English character. So yeah, true. So let's try another. Let's try G. True. Okay. But this is a very cumbersome way. As you can guess that this might be a very frequent requirement, right? To match a smaller letter English alphabet. That might be a very, very common requirement. So in order to cater to that, we have something called a range in a regular expression. And what it does is, I guess you all are aware of the fact that Java uses Unicode character encoding. So in that, what happens is that every letter is provided a numeric value. Alright. So what we can do is we can specify a range as a lower character dot dash a character with a larger Unicode value. So A has a value of 65. So A has a value of 97 and small z has a value of 122. Lower Unicode value to higher Unicode value. This represents a range in a regular expression. Now, this is a much better way than to write small a, small b, small c all the way up to small z. So let us see if this works. True, right? Again, Q. Yeah, so it's true. So this is how ranges work in regular expressions. So say suppose now you wanted to have okay, so now let us say that you wanted to accept, okay, let me write this down, this is going to be slightly big. You want to accept a string of length 5, okay, that has all small, or rather capital, just for the sake of variety, capital English letters, okay, a string of length 5 that has all capital letters. If you want to accept this, what are you going to do? So we all knew that there is something called ranges in regular expressions, and we can make use of it because this has a lower Unicode value of 65, whereas capital Z has a larger Unicode value. It's 65 plus 26, whatever that is, 91. Yeah, I guess that is what it is. So we need a string of length 5. So 1, 2, 3, 4, 5. So let us see if this matches the regular expression. So yeah, we get a true value as the value that is returned by this matches. So again, as you can expect, that there must be some sort of a shorthand for mentioning the number of times that you match a particular character. In this case, we have written it down 5 times to get a string of length 5. But yes, we can make use of certain things that are called quantifiers in regular expressions. If I provide curly braces and give a number inside of it, it simply means that this character, whatever this character is going to match, that should be, or rather this pattern should be present 5 times now. So let us see. Yeah, so we get a true value. This is what it means. So again, if I give 6, it is going to return false. False, right? So yeah, that is what is meant by a quantifier. But these quantifiers, okay, they have another special feature. the general approach of writing a quantifier is some kind of a lower bound, comma, upper bound. This is the general approach of writing this quantifier. Okay, so this lower bound shows the minimum number of times that you want to match to this pattern, and this upper bound shows the maximum number of times that you want to match this pattern with one letter in the input string. Okay, so say suppose you wanted to accept a string of length 5 to 10, that is all capital English letters as a part of its characters. So what you can do is replace the lower bound with 5, the upper bound with 10, and now you can accept a string which conforms to the pattern required. So this is true, and so is this. Okay, and let's see. This is supposed to be inclusive or exclusive. Yeah, so it's 5 to 10 inclusive. Okay, this is a string of length 10. So that is there. Now there are 3 more quantifiers. This is actually the one quantifier that you need to know, this lower bound and upper bound surrounded by curly braces. Okay, this is the one quantifier that if you know, you can actually do everything that you need to do with quantifiers in regular expressions. But it so happens that in practicality, a few of the quantifiers are used very commonly. These are 0 or more, and yeah, by the way, if you do not specify an upper bound, it means any number of times. Okay, so if you wanted to accept a string of length minimum 5, okay, of length minimum 5, then you could do it in this way by specifying 5 comma. Okay, so this should again compile to true. Yeah, so true. So this is one of the quantifiers that appears very regularly. The other one that appears very regularly is 1 or more. Okay, another quantifier that appears very regularly is 0 or 1. That is, either it comes or it comes only once. Okay, and I guess this is all. So there is a shorthand for this quantifier which is called the star. There is another shorthand for this quantifier which is plus, and the shorthand for this one is supposed to be a question mark. Okay, so you could write this. Okay, so obviously there does not exist a quantifier for 5 or more, but yeah, if you wanted a string of length 0 or more, okay, that is either no string or a string with all capital letters, that is what this signifies. So instead of writing this, you could also have written this, and it would have been the same. So see, yeah, so see, this is true. Okay, but give a small letter and you see that everything breaks down. Okay, let me clear this up. Yeah, so it's a false. Okay, now let us see. Okay, so if you were to supply a null string, or not a null string but an empty string, what do you think the output will be? So we know that this star is a shorthand for 0 or more, which means that this string also conforms to this pattern because it has got 0 capital letters and nothing else. So yeah, so you see, true value has been returned. Now let us check out the plus quantifier. This is going to give a false value for an empty string. Okay, that's it. It's a false value. Okay, but if you have at least one capital letter, it will give you a true value. Let us try out a few more. Let's compile it. and run it to get a true value. Okay, so that's that. Now we can also check out the question mark if you want. Okay, so this confirms to it, and we also know that it can also accept no characters. So this should also return a true value. So yeah, that's true. Okay, so now we know about quantifiers, ranges, and also how to provide a particular position with choices. That is like this, any of the letters from this range. Okay, so let us say that you wanted to write a regular expression to accept either these either a boy or a toy. So boy or toy. Wanted to accept any of these two strings. So what would you do? You would simply give B or T. That is the first position can be occupied by either B or T, followed by a O and a Y. And now you can give the input as a boy, run it, and it's a true value. Give the input as a toy, and it will still run. Yeah, so it's true. Now another thing is that here we have seen that how we can apply these quantifiers to particular ranges or to individual characters. Okay, but you can also apply the quantifiers to a group of characters. Say suppose you wanted to accept a string that was this, the pattern AB repeated any number of times. So how are you going to show that? Okay, so strings like AB, 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 these are going to be accepted. So how are you going to do that? So since you have a group that you want to repeat, you can make use of the parentheses AB, and what should be the quantifier here? Any number of times. So 0 should also be accepted by that logic because that is 0 number of times. So yeah, we can give a star, and we will see that this is exactly what we need. True. Okay, so this is the string that confirms to it. So try out something else and you will see that it's a false value that is being returned. Okay, yeah, so I guess that's it for regular expressions. And now you can, now whatever I've taught you here about regular expressions is something that is not dependent on Java. You can do it in any language. These concepts shall remain the same. It's just that different language will have implemented this regular expressions functioning in a different way. In Java, it is done through this regular expression package and then through the pattern class and the matches class. If you have not seen the previous video on regular expressions, I shall provide a plug on the top. You can go and click that and see the video too. And say suppose in Python you will have some different implementation of these functionalities, but these regular expression concepts shall remain consistent because it's basically the fundamental of computer science. So if you take a later subject on theory of computation, you shall learn more about finite state machines and regular expressions and all of those things. So yeah, that's it for this video.